through the Groundwater Information Network, which is essentially the data component to the former Geoscience Groundwater Program. And the abstract looks something like this. So the GIN, as the information is called, is both a data delivery and management mechanism for the groundwater program itself. It's also a national groundwater data collaboration with all the provinces and territories, so all the major data providers of groundwater information in Canada. And it's also a data delivery and a data delivery system management. It's helping deliver all this groundwater information for the country in some standardized way, as if it was a seamless whole. In fact, it's a bunch of distributed sources. To make that happen, there's some underlying connections to international both institutions, agencies, as well as data networks, so that if we have a connection of groundwater data in Canada, it's linked, for instance, to the US and to other international efforts, in fact, global groundwater data network. And then there's standards research and development that happens underneath this to make it all happen, and all of these are occurring in GIN. Not just for the last 5 years, but really to the last 15 years, because GIN has been around since 2009 as a groundwater program. The current team has shrunk quite noticeably. It's quite small internally. It's us four here with some notable members from the past. But this is just a small snapshot because, as I mentioned, the activities really range, various activities range both nationally, continentally, and internationally. So the whole variety of partners, including people from the provinces and territories, people from the US, Europe, and Australia, all involved in various activities. So the list is quite large, and I was going to start sticking up all the different icons here. But many thanks to the current members and previous members for making GIN possible. The motivation for GIN actually can be found in all the state-of-the-art reports and state of groundwater, reports from the country starting from 1995 leading up to pretty recently. Basically, from the data side to one main finding, that groundwater data is hard to find and use. That's partially because the data is distributed amongst independent and autonomous data providers, different formats, different protocols used to collect that, different content. It's a big mess, like most other scientific data, and users just find it very difficult to get all the data they need. They have to go to multiple providers, do a lot of complicated work to get it into a format that they can use for their purposes. So the recommendations from across most of these reports is we need more data online, and we need it more consolidated in a form that is standardized so that it can be much more easily usable. And that was came to a head essentially in a Senate of Canada report in 2005, where they strongly recommended that the Canada can create something called the National Groundwater Database, which we interpreted and more into a GIN, Groundwater Information Science Network. So that's the history. Secondly, we were mandated to do something like this, although we chose what to do ourselves by the Senate of Canada. A little bit behind the scenes, so we understand what we're talking about in terms of the actual data delivery system. But as I said, that's not the only component to GIN. There's the research component and there's the collaboration component, which is also very strong. But in terms of what's happening under the hood technologically, we have a set of independent data providers across the country, including the groundwater program itself. Some of that information gets centralized into a national repository managed by GIN. For instance, all the water wells across the country and all the monitoring stations now across the country are centralized into a component that gets fed regularly from the source data. And then other thematic layers are not centralized, but are taken from their sources. And these are all shipped to a standard which make sure that access to the data for both data content and data access is in a standard format, so that applications on the other side, and there's numerous applications that could access this data, could plug into it easily in a common way. So through this one standard pipeline, GIN is now accessed, for instance, in its own portal, which has some specialized content and functions not found in other portals, but also by other portals such as GGP, the Open Science Data Platform that we heard about yesterday, GOCA, as well as the Global Groundwater Monitoring Network portal, which is managed by the UNESCO and agencies associated with it. So basic message is data is managed independently. It's filtered to some central repositories or not, but filtered through a common pipeline that can then feed various applications, mostly portals right now, but it doesn't take away from the fact that it could be fed to AI applications, for instance, that wanted to traverse these large distributed data stores and start making use of them all automatically without any human intervention. So it's all set up to allow that to happen, and we're seeing it slowly starting to happen a little bit. So what I'd like to recap are some of the main results of the last 5 years, put into portals, data, usage, and research. We had hoped before the pandemic to release a new version of the portal, so that was at the other end of the pipeline, which involves some changes to all components there, but this is just the far end of that pipeline edge of the portal. Pandemic and also heightened security has really derailed that process, so we're a bit behind plan there, but we expect to have a brand new portal out this fiscal year. Similarly, the framework in which GIN was built was readapted in partnership with the Climate Change Program for the Permafrost Information Network, which is a smaller version of GIN in the north for permafrost data. And again, running in parallel with GIN, we expect the new version to be released in this fiscal year also. A major development over the last 5 years was actually national coverage for the monitoring network. That's in the new version. It's not currently in the online version, but we currently do in prototype form right now have national coverage for all the monitoring networks all combined into a uniform data feed that can be accessed as one large data store. Now, this is something that really, I wouldn't say surprised us, but we were very pleased to see because we base the decisions we made for GIN that things like this would happen, and that is that we've received quite widespread take-up of the end products amongst different users. And I mentioned some of them already. The actual usage of the portal is fairly modest, about 1,000 users a month, under 2,000 downloads of information a year from it, which for groundwater data, very specialized piece of information is not unusual. Is reasonable, I'd say. But the pickup by other platforms feeding data into C1W, Groundwater, and some of the other portals that I mentioned is really great. That's what we were hoping to see, and we're seeing it now. So if you go to any of those sites, you will actually see data being fed in from the pipeline into its portals. 2 minutes. Oh my God. And then connection with the USGS. So there's a seamless groundwater network now between the USGS and Canada using the standards, and also plugging into the global groundwater monitoring network from UNESCO, which has fed into the state of global water resources reports that are being generated by the WMO on a yearly basis now, if you'd like. And the Canadian and, in fact, North American component is being developed by the connection of the global network into the national networks, and those are being summarized into these annual reports. So we have a direct line from work that you're doing to the data, to continental systems, to reports on the state of global groundwater through this kind of standardized data feed, which I think is really great, and it was great to see finally this happen, because this was the initial sort of vision that we had would happen with GIN, but we're starting to see it happen right now. Something that's a report and in plan, the ability to an aquifer dashboard is something we planned, and the report's completed. The idea is that we'd be able to have summarized information from the data source for any polygonal area in the country to represent a summary report of that area. We participated in international standards, particularly this standard called Groundwater ML that was led by the team. We're also leading some other standards with associated publications. This was adopted across many parts of the world, but has formally recognized recently by the World Meteorological Organization, adoption by UNESCO. And I talk about this for a second, because normally I don't talk about this to a scientific audience, but there's some basic theory underneath this information theory that has to happen for some of these standards to work. And it means basically looking what is the metaphysical rather than physical nature of, in this case, water features, where instead of understanding them in terms of the physical characteristics, we're trying to understand them in terms of metaphysical characteristics such as hardhood, attainment, dependence, etc. And we've shown from this that we can distinguish and understand them, water features in this way, such as lakes, rivers, aquifers, etc., using some of these basic precepts. And also, then, once we can use that to build better information models, we can use those information models to start better integrating and navigating water information across the internet and connecting it together. One of the biggest problems we have with the current system that I've described thus far is that even though we've improved access to individual data silos, we haven't necessarily connected information across those silos. So, for instance, if you had a groundwater gauge in a water well and you wanted to easily find out which aquifer it was crossing, which river it was near, and which monitoring station on that river might be close to you, it'd be very hard to do that without going to different databases, downloading information, and trying to troll through it. But what the Internet of Water precept is that, or concept, is that you can be able to do that by linking that information explicitly, making it available on the web, and allowing people to navigate that. And in fact, Google, Amazon, Microsoft all improved their search engines using this kind of technology, and then combined with what are called large language models. But all that is possible if you have these better information models and you start organizing all this data that way. That then allows these internet-based search mechanisms to find the data. Secondly, it means you don't have to go to portals anymore. You can use your browser as a search engine to find the information, and you need much more easily than we have in the past. So the vision is that you'd have this cordoned out version of the internet that would allow interconnected water information to easily be found, easily related to other information, so that it really cuts down on the ability to, well, it makes it more efficient to use the data. And so we prototyped that with the USGS across Canada, doing an example that I discussed earlier with monitoring stations, rivers, and water wells. Worked very well, and it's now been picked up by an effort within Canada to connect geoscience data overall, not just water data. And I'll end it there.